Imagine you stop typing code line by line. Instead, you say what you want. Add a login screen, test it, fix whatever breaks, and a worker goes off and does it. It writes the code, runs the app, opens a browser to check the button actually works, and comes back with proof. That is the idea behind Google Antigravity, which Google launched alongside its Gemini 3 model in mid-November of 2025. But anti-gravity is just the example. The real subject is a shift in how software gets built, where you hand a goal to an autonomous agent instead of giving it keystrokes. So let us see how that works, where it is genuinely new and where it quietly breaks. Google calls Antigravity a new agentic development platform, one that lets you work at a higher task-oriented level. The key word is agentic. You state what you want, and the agents work out how. Google's framing is that the AI goes from a tool in your toolkit to an active partner that plans and carries out whole software tasks on its own. That is marketing language, so hold it loosely. But the idea underneath is real. The human moves from writing every step to directing the work. The whole product is really two views. The first is the editor view, a familiar AI-powered code editor with autocomplete and inline commands, the kind of thing you know from Cursor or Copilot. The second is where it gets interesting. It is called the manager surface, and it is mission control. From there you spawn, orchestrate, and watch many agents working at the same time across different projects. And the agents do not just chat and emit code. A single agent reaches across 3 places. It edits your files, runs commands in the terminal, and drives a real web browser. That browser control comes from a dedicated model, Gemini 2.5 computer use, trained to operate a screen the way a person does. That 3-way reach is why it can build an app and then test it. A note on what it is built from. Underneath, Antigravity is a heavily modified version of Visual Studio Code, the popular open-source editor. Many reports go further and say it is actually a fork of Windsurf, a proprietary editor Google licensed for a reported $2.4 billion, which would make it a fork of a fork. But that second claim is reported, not confirmed, so treat it carefully. Critics also said the launch gave little credit to the open-source projects underneath. The takeaway is simple. It did not appear from nothing. It is a new layer of agent machinery built on a well-worn editor. So why does this matter? Think about the long climb of programming. We went from raw machine code to high-level languages to ready-made libraries to autocomplete. Each step let you say more with less. Antigravity is one more rung where the input is a plain spoken goal, and that flips the bottleneck. When one person can launch many agents at once, the scarce thing is no longer how fast you type. It is how fast you can check the output. The hard part moves from writing to reviewing. That is the real bet here. That the editor should be built agent first, the agent as the main act, rather than a human editor with a small AI helper bolted on the side. So what can it actually do? The agents write code, launch the app, test the pieces, change the codebase, and do background cleanup without you approving each step. The standout move is that browser check. The agent spins up a real browser to confirm the interface works, then captures screenshots and screen recordings as proof. It can run many agents in parallel, so you delegate several streams of work at once. And it remembers, saving useful context and code snippets to a knowledge base, so later tasks start smarter. If it goes the wrong way, you do not start over. You leave a comment directly on its work, the way you would in a shared document, and it folds your feedback in on the fly. Hold on to that idea of proof. It is about to become the center of the story. Now the engine. Underneath every agent is a loop. It goes plan, act, observe, reflect, and repeat until the goal is met. This is the standard pattern behind essentially every agentic system, often called the reason and act loop. The agent plans, breaking your goal into steps. It acts by using a tool. It observes the real result, the terminal output, an error, what the browser actually showed. Then it reflects, critiquing its own result and loops. It writes a script, runs it, reads a syntax error, fixes the bug, and runs it again until the task is done. The tools change. The loop does not. Let us slow down on that word act because it is the part people get wrong. The model itself does not run your code or click the button. It decides which tool to call. There is a clean way to say it. An agent is a language model plus tools plus a loop. Edit this file. Run this command in the shell. Open this page in the browser. The model picks the tool runs, and the result flows back as text it can read. The standard name is tool use or function calling. The model is the brain, the tools are the hands. And reading back what the hands did is the whole trick that lets it course correct, instead of guessing once and hoping. Here is the single most important idea in this story. When the agent finishes a chunk of work, it does not dump a wall of raw tool calls on you. It produces what Google calls artifacts, verifiable deliverables, a task list, an implementation plan, a screenshot, a recording of the browser actually using the app. The agent checks its own outcome, runs the test, records the screen, and hands you that evidence. And this rewrites your job. Instead of reading every line of code, you audit the proof of work. That is what makes one person supervising many agents even possible. But be honest about what an artifact is. A green screenshot or a passing test is proof you can inspect. It is not proof the work is correct. An agent can hand you a convincing result while the code is subtly wrong. So treat an artifact as evidence to check, not a guarantee. Now put it together at scale. The manager surface is mission control for a fleet. One person spawns, watches, and steers many agents at once, pulling from that shared knowledge base so the loop gets smarter over time. You are an orchestrator, not a typist. And the deep change is in what you specify. You stop describing the procedure, every edit and every command, and start describing just two things: the objective and the acceptance check. It works when the test passes or the page renders. The agent owns the how. You own the goal and the judgment of the proof. Here, the harness is largely separate from the model that powers it. At launch, you could pick the lead brain, Gemini 3 Pro, or Claude Sonnet, or an open weights model from OpenAI called GPT-OSS. Same harness, different engine. But there is an asterisk. Google confirmed that even when you pick a non-Google model as your lead, background agents still run its own Gemini. So you choose the lead reasoning model, but some background steps may still run Gemini. Not, you control every model end to end. So how does it stack up? Take GitHub Copilot, the broadly compatible assistant inside your editor, whose edge is deep GitHub integration. You can hand its agent an issue directly and it opens a pull request, which Antigravity does not natively do. Then there is Cursor and Windsurf, the AI native editors, prized for fast inline loops but built around one human at one editor. And there is Claude Code, a powerful autonomous agent that lives in your terminal. Same agent loop DNA, just a bare command line instead of a full editor. Antigravity's distinctive bets are the manager surface running parallel agents and artifact verification. But to be honest, it is not a clear category winner. On one common coding benchmark at launch, it landed roughly a point behind Claude Sonnet, and security findings kept it out of serious enterprise use early on. Those numbers move constantly, so take any single score lightly. No single tool wins every case. So how do you get it and what does it cost? You download it free from Google's site on macOS, Windows, or Linux, pick a lead model and type a goal. That part is easy. The cost story is messier and changes fast, so here is the durable shape. At launch, it was free for individuals with generous limits. Within weeks of launch, reports said that free allowance was cut sharply by something like 90%, and paid tiers appeared. Google has not promised a permanent free tier. So the honest framing is free to start, but the allowance shrank quickly and paid tiers exist. Check current pricing the day you try it. And the idea kept spreading. About 6 months after launch, the same agent machinery showed up as a desktop app, a command line tool, a developer kit, and a way to run managed agents through Google's API. The lesson is not the feature list. It is that the agent loop kept generalizing onto every surface, a sign it is a basic building block, not just one feature. Now the part you should not skip. The defining risk of an agent like this is something called prompt injection. It reads web pages, reads your files, and runs shell commands. So shortly after launch, security researchers showed an attack chain end-to-end. They hid instructions in tiny, near-invisible text on a web page. When the agent read that page, it followed the hidden orders, found secret keys in a project file, and slipped them out to an outside server, even working around a protection that should have hidden that file. Separately, others found a way to make the agent run arbitrary programs through a flaw in its file search tool. These were real, demonstrated, and dated. Google logged some, patched others, and paid a bounty for one. So treat the exact attacks as history, not as how it behaves today. But the deeper lesson is timeless. Any agent that can read the open web, read your files, and run a shell is inherently attackable. That is a property of the design itself, which is why trust here is engineered, not assumed. Containment, sandboxes, allow lists, throwaway credentials, and a human reviewing the work is not optional. It is the point. Before we close, a quick myth check. It is not a fancier autocomplete. The news is agent-first orchestration, self-verification with artifacts, and many agents in parallel. You do not fully control which model runs your task, since background steps may still use Gemini. That third model option is not the famous chat model. It is an open weights model from OpenAI. Self-verifying does not mean correct, and agentic coding does not mean no humans are needed. The work does not vanish, it moves. So step back. The programmer is shifting from author to director, and the rare skills become asking for exactly the right thing and reading the proof of work with a critical eye. One person calmly supervising a fleet of agents is a preview of where software work is heading, where the unit of work becomes a delegated goal. And the load-bearing idea underneath all of it is verifiable evidence. You can only trust without rereading everything if the agent shows you proof you can inspect. So as we hand machines more autonomy, the central question becomes, how does it prove it did the right thing? Here is the whole thing in one line. We are moving from telling computers exactly how to do something to telling agents what we want and checking their proof of work. And anti-gravity is one early, imperfect picture of that shift.